Welcome to my channel. Today in this video we talk about 11th class chemistry, chapter 1 basic concepts, and we are going to solve the numerical 17 from the exercise. The question from numerical is: serotonin is a compound that conducts nerve impulses in brain and muscles. It contains 68.2% carbon, 6.86% hydrogen, 15.09% nitrogen, and 9.08% oxygen. What is its molecular formula? In this question, we are given by the molecular mass of serotonin, which is 176 gram per mole. And also we are provided with the percentage composition of carbon, hydrogen, oxygen and nitrogen. And what is required in this question? It is the molecular formula. We have to determine the molecular formula of the serotonin from the given data. As this question is from the combustion analysis, so we have given the percentages of the elements of carbon, hydrogen, nitrogen and oxygen, and we know that percentages are the amounts of different elements from 100 gram of the compound. So the given percentages are actually the number of grams of carbon, hydrogen, nitrogen and oxygen, and we have the data. Number of grams of carbon is 68.2 grams and hydrogen is 66.86 gram, nitrogen is 15.09 gram and oxygen is 9.08 grams. Students, for the evaluation of the empirical formula from the combustion analysis, we have to recall the steps for the determination of the empirical formula, and the steps are: number one, find out the number of chroma atoms or the number of moles, and you can use the formula N is equal to small m over capital M. And second one is that if we have determined the number of moles or the chroma atoms, then we have to find out the atomic ratio of the elements, that is carbon, hydrogen, oxygen and nitrogen. So when we divide all of the number of gram atoms from the smallest value, then we have the simplest atomic ratio. And that numerical simplest atomic ratio is actually the empirical. So recall the formula N is equal to small m over capital M, and then we are going to calculate number of moles by using the data. Here you can see in this table the given amount in grams of the carbon, hydrogen, nitrogen and oxygen are given in left hand side, and number of moles are calculated by using the formula N is equal to small m over capital M on the right hand side. So from carbon mass 68.2 grams, we get number of moles by dividing this amount by 12. 12 is the atomic mass unit of the mass molar mass of carbon. So 68.2 over 12 is equal to 5.8. And in the similar way, we can divide the mass of the hydrogen, that is 6.86 gram over 1.008. So it gives 6.8 gram atoms. And now execute the same formula for nitrogen and oxygen, and we get number of moles for nitrogen 1.07 and for oxygen 0.56. And now we go further to find out the atomic ratio. So simply divide the atomic ratio 5.7 by 0.56, and 0.56 is the smallest of the number of moles we have calculated from the previous table, so it gives out 10. And for the same reason, for hydrogen we can divide 6.8 over 0.56, which comes out to be 12, and for nitrogen 1.07 over 0.565, it comes out to be 2, and 0.56 over 0.56 for oxygen, and it comes out 1. So we have carbon atoms 10, hydrogen 12, nitrogen 2 and oxygen 1. So it implies the empirical formula. So the empirical formula is C10H12N2O. As we have determined the empirical formula, so we have to determine next the empirical formula mass, and it can be calculated by multiplying the atomic masses by the respective number of multiply by 1, and the answer comes out to 176 gram per mole. This is actually the empirical formula mass. Now the relationship between the molecular formula and empirical formula is used to determine the value of n. So molecular formula is equal to n multiplied by empirical formula. So it gives n is equal to molecular formula mass over empirical formula mass. So n is equal to, by putting the value 176 over 176, it comes out to be 1. So n is equal to 1. And now putting the value of n is equal to 1 into the relationship, and the relationship is molecular formula is equal to n multiplied by empirical formula, which gives molecular formula is equal to 1 multiplied by empirical formula, which we have calculated in the previous section, that is C10H12N2O. So the molecular formula comes out to be C10H12N2O, and this is the molecular formula of serotonin. So this is the answer of the question. This is the simplified chemistry for you. The channel is the MS Gun.